Okay, so the free body diagram again goes all the way from the pin. So we still have this negative 142.8, negative 464.5, and now we're going further than 0.25. So for any of these infinitely many values that we're considering, we're including this point force of 7071, negative 7071. And then we have tension, shear force, and bending moment. And this cut is valid for x between 0 and 0.5, non-inclusive. Newton's second law says negative 142.8, negative 464.5, plus 7071, negative 7071, plus T0, plus 0, negative V is equal to zeros. And the rotational equation, I'll still do it about the pin. So we have a moment arm of 0.25. This downward force of 7071 would create a clockwise rotation, so that gives you, well, negative 0.25 times 7071. Plus m minus Vx is equal to 0. And if you solve that, you get T is equal to negative 6928.2, right? People got the same thing? Second, the shear force, I got negative 7535.2. Is that right? And bending moment, now we have this linear function with a constant in it, negative 7535.5x plus 1767.75. You get the same thing? Anyone get something different from that? Okay, and these are valid for x in the range of, so what x values are these? What did I say? I told you the wrong thing here. And this is sort of a confusing, this is something that's easy to get confused about, and even easier when I tell you stuff that's wrong. This is valid for x from 0.25 to 0.5. Okay, so there's sort of two things at play. There's the set of x's that are kind of included in our free body diagram. That's from 0 to something less than 0.5. But those aren't the x values we're looking for, okay? The x, because notice that x only represents the distance from the end to this endpoint, okay? And so we're only dealing with endpoints that go from 0.25 to 0.5. You know what I mean? So try not to get confused on that. Also, I want to stop and ask a question here. What if I I'd chosen as my free body diagram, instead of going all the way from the left, I chose to start at 0.25. Okay, so I start here, with this force of 7071, negative 7071. And I'm asking this because this is a mistake that I've seen a lot. And then we don't quite get to the 0.5, so all we have left is T, V, and M. Okay, so this is wrong. Why, like, what's wrong in the thinking here? Yeah, exactly. So there's one set of loads we're not considering. We are considering this external load at 0.25, but there's something else happening. And what we're skipping is that in addition to all those other loads, we have some, I'll call it T1, shear force 1, bending moment 1, that are acting between the metal we're omitting and the metal that we're including. Okay? And that's why you can't do it like this. And that's why you always, what you could do is you could go from the right side instead of the left side. Or if you wanted to be really tricky and make things, being tricky a lot of times makes things really hard for yourself. You could go back to this formula we just found here. These are the TV and bending moment that are valid from 0.25 to, or from 0 to 0.25, right? So you could use that formula somehow in here. Actually, I'm not sure how, but I'm sure you could figure out a way to use that formula in addition to this other formula and represent that. But that would be crazy. Makes no sense to do that. And that's why we always start it all the way at the left for all of these cuts, okay? Because of the complication of extra internal loads if you cut anywhere else, okay? Any questions on that point I'm trying to make? All right. We have one more cut to make. And that's dealing with the x values from 0.5 to 1, non-inclusive always. So I'm going to need you to go ahead and work together on this. It's not a half of a practice problem, okay? I'm going to need you to go ahead and do the full problem. Okay, and then when you're done,